Okay, 718ers, let's begin our ascent up Mount R. We're going to talk about objects and functions first to get us started. And it's reasonable that we do this. Take a look at this quote from John Chambers, who you may remember created the S programming language, which was the predecessor of R. To understand computations in R, two slogans are helpful. Everything that exists is an object. Everything that happens is a function call. Literally everything that exists in R, and literally everything that happens is a function call. So you're talking about existence and happening. That's pretty much the whole show, isn't it? I think we have it right there. As I work through my notebooks, you have access to these, so I recommend that you follow along with me. In this notebook, we're going to explore the basics of objects and functions. Now, all objects have a mode, a class, and a type. The mode is the classification of the basic structure of the object. The class is a property of the object that determines how functions can operate on that object, and the type tells us what type of data are contained within the object. For us to do anything in R, we need to use function calls because, remember, everything that happens is a function call. Here I'm going to use three function calls to look at an object. I'm going to look at the mode, the class, and the type. So let's go ahead and do these one by one. You can follow this and watch in my console window here. Let me go ahead and maximize that for the time being. So let's find the mode of 2. Is 2 an object? Indeed it is. Everything is an object. What kind of object is it? What's the mode of the object? The mode is numeric. The class is also numeric. Now remember that class is a property of the object that determines how functions can operate on that. So any function that can handle numeric data can operate on 2. Oftentimes, the mode and the class are the same thing. We're going to actually be focusing more on class in this class. So we're not going to talk so much about mode. Let's take a look at the type of data in the object. That's called double. Double is the name used for real numbers. That is anything that can have decimal points to it, as opposed to integers, which cannot have a decimal portion to them. So the number 2, even though you don't see it here with a decimal point, it assumes that 2 is a real number that could have a decimal point. It could be 2.1 or 2.4. If I were to take, for instance, and take the type of 2.4, I still get a double. So there's no distinction here between 2 and 2.4 in terms of being a real number. There are 4 basic modes for data objects: numeric, complex, which we're not going to deal with in this course, character, and logical. 3 of those, numeric, character, and logical, we will deal with, but what's more important to us is the class of the object. So that's what I'm going to focus on throughout the course, are object classes. Let's think about classes of objects in the world. You can have houses, you can have vehicles, you can have animals, you can have toys, furniture, electronics. These are all classifications, are they not? In R, we can classify into vectors, matrices, arrays, factors, lists, and data frames. There are other classes of objects in R, But these are the ones that contain data. And since we're interested in using R for manipulating and analyzing data, these are the ones that we're going to focus on the most. But every object, including functions, have a class. So the first class we're going to look at, naturally enough, since it's first on this list here, are vectors. And vectors are hugely important in R. Vectors are really the basic building block in R, the basic data type, the basic classification that we can have. A vector is a sequence of data elements. Now, if you think about that a moment, that a vector is a sequence of data elements, and then if you think about statistics, in which you calculate statistics based upon what? Sequences of data. You can already start to see the connection between R and statistics. And R was created by two statisticians to become a statistical programming language, so it's natural that the basic building block for R is a vector, which is a sequence of data elements. An atomic vector is a sequence of data elements of the same type. So as long as your vector contains the same type of data for every data element, we refer to it as an atomic vector. And that's what we're going to be looking at first. The types of data elements that you can have within a vector are logical, integer, double, complex, character, and raw. Note my asterisk, we're not going to use these, but that leaves us 4 types of data that we are going to use. Logical, integer, double, which you already know is just real numbers, and characters. So let's go over here and start looking at atomic vectors, a sequence of data of the same type. Now, to build vectors, we concatenate, that means combine or put together, the members of the sequence with the concatenate function. The concatenate function is given just with the letter C. We can then assign this to an object we create with the name that we choose. So here's an example of a vector. Here on my line 44, notice C with the parentheses on either side. So that's indicating to us that we're using a function, and what you put in parentheses is called an argument. So we're actually putting in quite a few arguments here. 2, 4, 6, 8, 10, 12, 14, 16. Depending upon the function, it might want one argument, no arguments, or a bunch of arguments. As you see here, we're giving it a bunch of arguments. We're concatenating those together now into a name, an object that I have named even nums. You can name it anything you want. You could name it Bob. You could name it elephant. You can name it anything you want. But I recommend, especially getting ready for the day when you're going to write longer scripts, that you name the object something that makes sense. If all your objects have names like Bob or Sarah or Tony or Raphael, then when you write your script, it's going to be hard to keep track of what's what. I understand that it would give a nice personal feel and they would quickly become your friends and you would feel happier about writing your scripts. But let's get happy with names like even nums to indicate that this is an even numbers in a vector. So let me go ahead and create this even nums. But before I do, I'm going to open my environment window, which right now is empty. But when I create even nums, it now appears in the environment here, and you can see the vector in its entirety. If it was a longer vector, you would have ellipses to indicate there are more elements that you're not seeing. But in this case, we can see the entire vector here. This indicates to us that it is numeric data in the vector, and this indicates to us that there's 8 elements numbered 1 through 8. So number 2 is in the first position and number 16 is in the 8th position. Let's take a look at the class of this object. We're going to do it naturally enough with a function called class. The class is numeric. Now, why did it not say vector? All vectors have a class that are indicated by the type of data that they contain. So if you see the type of data for a class, you know that you're dealing with a vector. All the other data structures we're going to look at, when we look at the class of them, it is going to give us the data structure as the class. But for vectors, which are the basic building blocks of R, the class is going to be the type of data contained in the vector, that is, what is the atomic nature of that vector. So the class of this vector is numeric, meaning that it has numbers in it, and any function that can deal with numbers, including functions that can deal with decimal points, can operate on 2, 4, 6, 8, 10, 12, 14, 16 are even nums. If we look at the type of data that we have, we see that it is double. Now you might say, wait a minute, you just said that the vector class is named by the type of data it contains. Double is actually a subset of numeric. There are 2 types of numeric data in R: doubles, which are real numbers, or integers, which have no decimals. Both of those are considered numeric. So the class of the vector is numeric, which is one of the types of numbers that we can have. We can have doubles or integers. What if I wanted to have it as integers? To do that, we have to add L to each of the numbers. So now, if I put in even numbers 2, I have integers 2, 4, 6, 8, 10, 12, 14, 16. The class of even numbers 2 is an integer, and the type is an integer. So we end up with numeric data regardless of whether we're using integers or doubles. Now, pause for a moment. Remember what I said about class and why it's so important. Because the class will indicate to functions what kind of functions can actually operate on that vector. And so if you have a function in which you can not operate on doubles, but you can operate on integers, that is, it assumes that there are no decimal points. The fact that this class is integer means that you can use that function on that class even though you wouldn't be able to use it on even numbers, which is double.